Okay everybody, welcome back. This is Mr. Oliver. I'm going to go ahead and start you guys out on your next flip lesson, which is going to cover modeling. Modeling what? Well, I'm glad you asked. It's going to be on modeling multiplication with fractions. Here's our learning target right there. And here's our learning target. I'm going to start putting those in our videos from now on. But we have a learning target. You, the student, will construct. You're going to make a model of fraction multiplication problems. So that's what we're going to be doing. You're going to be doing something like this. You're going to be drawing a picture. It's going to be a very visual way of multiplying and showing how multiplication of fractions works. Okay, let's go ahead and get right into our first example here. What we have is a typical multiplication problem with fractions. 3/4 times 2/3. And another way to think of multiplication is by thinking of multiplication not as just multiplication, but thinking of it as the word of. 3/4 of 2/3. What does 3/4 of 2/3 look like? That's what we're going to be doing in our model. So what I'm going to do first is I'm going to draw a model of thirds. Now this model right here, you'll notice that I broke it up into thirds. Here's a third, here's a third, and here's a third. Okay, it's been broken up into thirds. Now I know that we're looking for 3/4 of 2/3. So I'm only going to shade in 2 out of the 3/3. And you'll notice right here that the shading is in one direction. So when you guys are doing this, you're going to want to shade one direction for one of the fractions. In this instance, I'm doing 2/3. And you'll notice the direction that I shaded was this way. So that's the way we're doing it. And then when I do the other fractional part, I'm going to shade in another direction. So here's 2/3. You'll notice that it's all shaded. You're all noticing that. I'm going to split up this model into fourths, into quarters, and I want to look for 3/4. And this time, I'm going to go this direction. So now we have everything there. And you'll notice that when we shaded in the fourths, my shading was going another direction. So it's going this way. And then that makes it, if you look at the shading, it makes it really easy to spot where the intersection of those fractional parts are. Right here you'll notice some of the boxes are shaded both directions. Both directions here, both directions. Now you notice right here it's only shaded one direction, so we're not going to count that. Here, nothing is shaded. Here, it's only one direction. Here, it's two different directions. So what we're going to primarily focus on is the model part that is shaded in both directions, both left and right. It's shaded. So right there. Now that is our answer. That's our answer. So now that you have your answer, I think the tricky part is just understanding what it all means. How is this our answer, and what does it tell us about our answer? Well, what did we split the box up into? What are these parts called right here? What are these individual squares called? Well, I count, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So these are all twelfths. So that's 1/12. That's another 12th. This is another 12th. These are all called twelfths. So how many twelfths are shaded in both directions? Well, I'm counting 6 twelfths. Here's 1, here's 2, 3, 4, 5, 6. 6 out of the 12, there's 12 total there, 6 out of the 12 are shaded both left and right. So what does that come out to in the very end? Well, let's check it out. All right, so 6 twelfths. Now, one thing that you always have to remember to do is that you always need to reduce. 6 twelfths, I'm sure you're thinking already, and you already knew this, but I'm going to say it anyway. 6 twelfths reduces to what? 1/2. So really, if you really look at it, I know it's kind of hard to tell because it's not shaded in a typical manner, but if you look at that, half of my model is shaded both this way and this way. 1 out of every 2 squares is shaded in both directions. Okay, how many squares are there total? How many squares are there? There's 12. How many are shaded in both directions? 6 out of the 12, so half of it. That's the answer. 3/4 times 2/3 equals 1/2. Okay, should you always simplify? Yes, always simplify. Before I go on any further, what this is all called is, I'm showing you how to model, but what this is called, this is the area model, because we're literally looking at the area. What area of the whole rectangle, is shaded in both directions? So we're using the area model. That's what this is all called. So if I use that term again, if I use that phrase again, area model, you'll know what I mean. Next example here. Now in this example, we have 3/5 times 1/6. Again, we want to think of multiplication as of. What is 3/5 of 1/6? All right, so let's go ahead and draw 1/6, and then you'll notice here this has all been broken up into 6. And I'm doing it a different way than I did the last one, because it doesn't always have to be done the same way every time. But you'll notice on one side I have horizontal lines that are splitting the fractional model into 6. Okay, each one of these strip is considered a 6. That's 1 6, this is 2 6, 3 6, etc. Right here we have 1 6 shaded in, and you'll notice it's shaded in this direction. So when I do the other part, when I do the vertical lines, not exactly what it's going to look like, but when I do the vertical lines, I'm going to shade it the other direction. I'm going to use a different pattern with my shading. So there's what 3/5 looks like. I just broke it up into fifths. Alright, so let me just kind of show you. Here's a fifth, here's another fifth, here's a third fifth, here's a fourth fifth, sounds kind of weird, and here's your last fifth, 5/5. So you'll see my fractional model going this way. We broke it up into fifths. So now what I'm going to do, shading in a different direction, because you'll notice that I shaded the 6 in this direction. So when I shade it the other way, I'm going to make different. I'm going to put my shading in a different direction. There's 1/5, there's 2/5, and there's 3/5 right there. There's our answer right there. That part of our whole, of our fractional model, is shaded both this way and that way. This way and that way. The rest of it is either not shaded, right here, or just shaded one direction. There you go. So this is our answer. So what does that stand for? What does that equal? And in order to do that, well, let's figure out what each one of these equals. How many parts did we break it up into? To spare us having to count each and every one of these little squares, let's look at this, because this is area. 1, 2, 3, 4, 5, 6. So it's 6 this way, 5 that way. That makes 30. Alright, so we broke it up into 30 parts. So how many 30ths are shaded in? It's not very hard. It's very easy to count. 3 30ths. What does that reduce to? That reduces to 1/10. So 1/10 of it is shaded. In this example, I'm going to show you how to model multiplication of mixed numbers. And you'll notice that I have 4/9 of 2 1/8. So I'm going to start by modeling 2 1/8 first, and I'm going to break it all into 8s because I want to do 2 1/8. And there you have it. Here's what 2 1/8 looks like. We have one hole here, we have 2 holes here, and then we have 1/8 of a hole there. 1, 1, 2, and then 1/8 right there. Notice in the entire model, I split up everything into 8s. Not just the last part, but everything. Even the 2 holes are split up into 8s. What does that equal? That equals 8/8. What does this equal? That also equals 8/8. What's this equal? That equals 1/8. What's 8/8 equal? Equals 1. So what do we have here? We have 1 plus 1, which is 2, 2 1/8. Hopefully you guys all understand that by now. We've talked enough about fractional models to kind of understand that by now. If not, you need to let us know. Now it's kind of hard to see, but I shaded my 8s in this direction. So when I do the other part, when I do the 4/9, I'm going to shade them in a total opposite direction. So now I'm going to break it up into 9ths going this way, which is, I understand, not very easy. Okay, so there's our 4/9 right here. That's 4/9 right there. I've shaded in 4 rows, 1, 2, 3, 4 out of 9. So believe me, there's 9 rows there. And all I'm going to do is figure out how much of this is shaded in both directions, right there. Now before I do that, and again, you don't want to count each and every one of these individual squares, but I need to figure out what these represent. What do these little squares represent? Well, this square represents a part of the whole, a very small part of the whole, but we need to figure out. And then I notice that this is 9 by 8, 9 horizontally and 8 vertically. That makes 72. So this right here is 1 out of 72. So what I'm going to do is I'm going to figure out how many out of 72 is shaded in both directions. And again, I want to spare you having to count one by one, 1, 2, 3, 4. That's going to take a long time. So let's go ahead and just look here. All right, so we have 4 in this row that's shaded in both directions. So that's 4, and then how many rows do I have? I have 1, 2, 3, 4, 5, 6, 7, 8, and then there's 8 rows there, and then there's 1 row there. So how many rows do I have and shaded in both directions? Well, I have 8 here, 8 here, that makes 16, plus another 1 makes 17. So what's 17 times 4? That is 68. I know how many I have shaded in. I have 68 out of 72 shaded in. 68 of these. That's a 72nd. I know that sounds kind of weird. This is 1 72nd. This is another 72nd. How many of those are shaded in both directions? 68 of them. Let's go ahead now and reduce. So 68 over 72, I know that can reduce by 2. Something a typical math student's going to do. 68 divided by 2, 34. 72 divided by 2, is 36. And don't stop there. Keep dividing. 34 divided by 2 and 36 divided by 2. 34 divided by 2 is 17. 36 divided by 2 is 18. So there you go. 17/18 is the answer. There you have it. 17/18, which seems kind of strange because usually when you multiply, numbers get bigger, right? Numbers usually get bigger. However, we're multiplying fractions. So when you multiply a fraction of a fraction, things are going to get smaller. That's just how fractions work. They are going to get smaller because you're taking a fraction of a fraction. I'm going to go ahead and start doing a summary for you here as well, and you need to write this down in your interactive notebook. If you don't have an interactive notebook, please get one as soon as possible. You should be writing all these notes in your interactive notebook, and any examples that I do, any writing that you do, any steps shown, you need to do that. So let's go ahead and answer some of these questions. I think I just threw these together as a little summary here. The first question is, what's another way to express multiplication? What's another way? Of. Of is another way to express multiplication. The next question right here is, what kind of model did we use? What kind of model was that called? And what we used was the area model, okay? Because what we did was we broke it up like we would something in geometry. How would we figure out the area of it? The last one there, usually when you multiply numbers, they get bigger. How come when you multiply fractions, they get smaller? And the answer to that question is because you're taking a fraction of a fraction. If someone offered you, and this is my example here, if someone offered you half of a quarter of a piece of pizza, you're not going to get much. You know, you're not going to get as much as you think. Here's a pizza, and there's a quarter right there. There's a quarter. And when you multiply that by 1/2, here's a fourth again. When you multiply that into half, a half of a fourth, that's all you're getting. Okay, I know it's at least something. You're not getting as much as you think. You're not getting more pizza. You're getting actually less of what was off. That's why when you multiply fractions, same thing occurs when you multiply decimals as well, because you're not dealing with whole numbers. When you're dealing with fractions or decimals, things get smaller usually because you're taking a part of a part. Okay, that concludes our lesson, everybody. I hope everyone understood this. Fractional models, they're not a bad way to do it, and they really do, I think, in my opinion, they really do show you how multiplication of fractions work. I think this is also easier than the adding and subtracting models, and I'm sure you appreciate that. So that does it, everybody. Have a great night. See you tomorrow.